So let's see this problem. In this problem, the variable x1 is given as unrestricted and the variable x2 is given as non-positive. So just solve this using the graphical method. The difference here is, अभी तक हम बनाते थे ये first quadrant. Now if you look at the problem, it says कि x1 can be either positive or negative or even zero. That means अब से हमें ये साइड भी बनाना पड़ेगा एक्सिस का. Okay, so this is the domain for x1, because x1 belongs to the real number 9. That means it is in unrestricted. Next, see the value that x2 is taking. x2 is non-positive, so that means यहाँ पे तो कभी भी x2 नहीं होना चाहिए, क्योंकि इस पे तो x2 is positive. That means जो ये हमने रीजन बनाया हुआ है फिलहाल, ये वाला तो क्वाड्रेंट नहीं आने वाला. क्वाड्रेंट कौन सा आएगा? नीचे की तरफ ये. तो ये x2 जरूर था, दिस वाज x2, बट फीजिबल रीजन हमारे लिए क्या है? क्या ऊपर का रीजन फीजिबल हो सकता है इस पूरे में? इस पूरे में तो x2 इज ऑलवेज पॉजिटिव. दैट मीन्स हमें रहना कहाँ पड़ेगा? हमें यहाँ पे कहीं रहना है. नाउ वी कैन स्टार्ट द प्लॉटिंग द कंस्ट्रेंट्स. इसको प्लॉट करते हैं. x2 is 0, so x1 is 2. So x1 is 2. When x1 is 0, x2 is minus 2. x2 is minus 2. 0, comma, minus 2. So these are the points. And the feasible region किस तरफ है? Put 0, comma 0. 0 minus 0 is satisfying. So the region is towards only. So the region is towards the origin. And this is the origin. This is the line. Now let's say we plot the second constraint. So x1 is minus 4. So x1 is minus 4. Now if you put x इसको 0, so x2 is minus 4. So x2 is minus. So the line becomes, so this is the line. Okay. And which side of the region, which side of the line you should be? 0, put 0. 0 minus 0 is satisfying because it is less than or equal to 4. So the region is towards the origin. So the region is this side. Now where is the common portion? Where is the common region? If you see clearly, the corners of your region are this, this. This is not a corner. One might get mistaken कि ये भी एक corner है, because this is not a corner. क्योंकि अगर आप यहाँ पे शुरू होते हो, यहाँ जाते हो, इसके बाद आप कहाँ जा रहे हो? यहाँ तो नहीं जा रहे, आप आगे मूव कर रहे हो, तो ये कॉर्नर तो नहीं बना. दैट मीन्स दिस इज अ कॉर्नर, दिस इज अ कॉर्नर, दिस इज अ कॉर्नर, एंड दिस इज अ कॉर्नर. So this is not a corner. So I'll just mark this. This is a corner, this is a corner, and this is a corner. Okay. So the region is, so this is the region boundary. Now where is the first corner is at minus 4 comma 0. The next is at 2 comma 0. And what is this corner? You solve the two lines. इसके लिए solve कर दो. Add them, this gets cancelled. Minus 2x2 is equals to 6. So x2 is equal to minus 3. So x2 is equals to minus 3. What is x1? Put this value of x2 in this constraint. So that would give you x1 as minus 1. So what is the objective? x1 minus 3x2. So the objective is इस पे minus 4. इस पे आएगा value 2. इस पे value आएगा minus 1. Minus 3 into minus 3. So this is 9. 9 minus 1 is 8. So the objective is 8. हमको maxima चुनना है. So maxima is this occurring at -1 comma -3. So the point of optima is x1 is equals to -1, x2 is equals to -3, z is equals to 8. So this is the optimal solution to the problem. So once again I'll tell कि ये corner नहीं है, ठीक है ना? This is not a corner. ये corner क्यों नहीं है? Because see x1 is said to be unrestricted. यानी कि x1 को इस partition से मतलब ही नहीं है. ये जो partition बीच में है, x1 को मतलब ही नहीं है उससे. So you might as well delete this also. Because x1 is not cared. x1 doesn't care कि ये है कि नहीं partition. x1 के लिए तो पूरा का पूरा ये space है. Once you say that it is unrestricted, so the entire space is there for x1 to roam around. तो ये पूरा space है x1 के लिए. I mean हम तो बस ये जो line बनाते हैं ये अपनी reference के लिए बनाते हैं. बट अगर x1 को फर्क ही नहीं पड़ रहा नेगेटिव पॉजिटिव से, तो व्हाई दैट बाउंड्री? सो दैट बाउंड्री इज जस्ट फॉर रेफरेंस. सो दैट कॉर्नर इज नॉट द कॉर्नर ऑफ योर रीजन. ओके. So in this question, we are asked to find the LPP's constraints, and then it is asked to find the optimal solution. And the region is given. So the region is in fact, this is the feasible region that is shaded in blue. So this is the feasible region of the LPP. We are asked to find the constraints. So first, let us mark the corners of our feasible region. This is a corner. This, 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 and this. So these are the corners. So this is simple. This is the origin. Let us name this A. This corner is also simple. It is 0, 1. Let us name this B. इसका नाम C रखते हैं. इसका निकालेंगे कोऑर्डिनेट. इसका D. This is E. This is F. Anything else? Okay. Now we start making the constraints. Now if you see the region, if this is the region, it is lying in the first quadrant. That means non-negativity constraints must have been there. So the first two constraints that are very obvious are x non-negative, y non-negative. So these two constraints are the yellow constraint. So this is the yellow, and then this. तो ये constraint तो हो गई सही. ये constraint रही होगी problem में, ये दोनों x and y being non-negative. Now let's focus on this horizontal line. This is at the height of y equal to 2, and the region is below the origin, below the line, facing towards the origin. Below है. So the constraint is y less than equal to 2. तो ये constraint भी लिख दी. This is say the red constraint. Now ये vertical line भी simple है. Passing through x equals to 3 and the region is towards the origin. So the constraint is, let's say x less than equal to 3. This is the constraint. तो ये constraint तो लिख दी हमने. Next we find the non-trivial constraints. Let's say we focus our attention to this constraint, ये वाली. Line की equation पता करने के लिए what you need is 2 points. See, the first point through which this line is passing is 0, 1. The next point is -1, 0. तो line की equation को पता करने के लिए हमारे को 2 points चाहिए होते हैं. So those 2 points are in fact 0, 1, and the next point is -1, 0. So this is the 2 points. This is say x1, y1, x2, y2. Line की equation क्या होती है? y minus y1 into the slope. Slope is y2 minus y1 upon x2 minus x1 multiplied by x minus x1. So this is the equation of that line. So the slope becomes positive. Y minus 1 is equals to x. So this is x minus x plus y is equals to 1. So this is the line. तो लाइन तो निकाल ली. कंस्ट्रेंट के लिए रीजन देखते हैं, रीजन कौन सा है. So the region is, see this is the line. Since the region is facing towards the origin, this is towards the origin. So this is in fact less than equal to 2. Okay. So we have found this constraint. So let us color this as say this. Okay. So minus x plus y minus x plus y less than equal to 1. Next, focus on this line. Oh sorry, this line. इस लाइन को पता करने के लिए you need 2 points. एक तो ये पॉइंट है जहां से ये पास हो रहा है और एक ये पॉइंट है. तो पॉइंट कौन से मिले आपको जहां से ये लाइन पास हो रही है. एक पॉइंट है 0,4 और एक पॉइंट है 5,0 और इसका स्लोप नेगेटिव आ रहा है क्योंकि tan 90 बड़ा है, 90 से बड़ा है एंगल. सो लेट्स फाइंड. सो द इक्वेशन इज y minus 4 is equals to 0 minus 4 by 5 minus 0 into x minus 0. So y minus 4 is equals to minus 4 by 5 multiplied by x. तो 5 को क्रॉस मल्टीप्लाई करके bring every x on the left hand side, तो ये हो जाएगा 4x plus 5y. कांस्टेंट को राइट में भेज दो तो 20. So this is the equation of that line. So we delete this. तो ये तो हो गई लाइन की इक्वेशन. नाउ चेक द रीजन. ये लाइन निकाली हमने. It is facing towards the origin. So if this is towards the origin, the sign is this because 0 plus 0 is satisfying. So इसका इक्वेशन भी निकल गया. So इसका इक्वेशन, let's color this as say purple. So 4x plus 5y is less than equal to 20. This is the constraint. 4x plus 5y less than equal to 20. तो LPB का कंस्ट्रेंट तो फाइंड कर दिया, तो फर्स्ट पार्ट तो हो गया. नेक्स्ट यू वांट टू फाइंड द ऑप्टिमल सॉल्यूशन. सो फॉर द ऑप्टिमल सॉल्यूशन व्हाट यू नीड टू डू इज फाइंड द कॉर्नर्स. तो देखो A और B तो पता है, C को पता करते हैं. C lies at the intersection of the red and the green. So ये red और ये green. तो you put y equals to 2 there. So this would make x equals to 1. तो x बन गया 1. So x is 1 and y is obviously 2 because this is the line y equal to 2. This is the line y equal to 2. Now let us find the point D. ये लाइन और ये लाइन के इंटरसेक्शन पे है ये D. सो पर्पल एंड रेड को सॉल्व करते हैं. पर्पल एंड रेड. सो पुट y इक्वल टू 2 इन दिस. तो ये हो जाएगा 4x plus 10 equals to 20. 4x is 10. x is equals to 5 by 2. तो x कोऑर्डिनेट तो आ गया 5 by 2. So y is 2. Let us find the coordinate E. E lies at the intersection of the blue and the purple. So blue पे x का वैल्यू तो पता ही है. blue पे x का वैल्यू is 3 because ये रहे वो 3. बस y पता करना है. तो इसमें 4 into 3 12. 5y is equal to 8. So y is equal to 8 by 5. So 8y, y is equals to 8 by 5. Okay. तो E पता हो गया. अभी पता करना है F. F lies at the intersection of the, अच्छा this constraint is left. Okay. So इस constraint के लिए you need to find 2 points. एक पॉइंट तो ये 2,0 है और एक -1, 0,-1 है. तो जो 2 पॉइंट चाहिए आपको आपके पास है to find the equation of a line. The first point is say 0,-1. The next point is 2,0. Okay. The equation of a line is y minus of -1 is 1. Y minus y1 is the slope is 0 plus 1 by 2 minus 0 x minus 0. So the slope is y plus 1 is equals to half into x. So the equation becomes x minus x plus 2y is equals to minus 2. So this is the equation of the line. So this is the equation. Constraint के लिए check करते हैं अभी. So this is the equation. Now this line says to be there, यानी कि towards the origin. Okay. So if this is towards the origin, the sign that you put there is in fact what? The sign is this time this. Because if you put 0 and 0, so 0 is greater than equal to 2. This is satisfying. अगर आपने ये साइन लिख दिया होता तब वो बात गलत, तब तो रीजन ये वाला बनता. सो दिस इज द साइन. सारों में साइन तो देखो यही चल रहा है, इसके लिए साइन इज दिस. ओके, सो लेट्स से दिस इज द ब्लैक कंस्ट्रेंट ओनली. तो हमें एफ निकालना था. एफ लाइज एट द इंटरसेक्शन ऑफ द ब्लैक एंड द वर्टिकल लाइन, दैट इज एक्स इक्वल्स टू 3. तो एक्स का वैल्यू तो पता ही है, एक्स का वैल्यू इज 3. तो इस 3 को यहाँ पुट कर देते हैं, तो -3 हो गया, ये उधर जाके हो जाएगा प्लस. 3 - 2 इज 1. y इज हाफ. y इज हाफ. एफ पता करिए. डी के लिए, डी सिंपल, डी इज नथिंग बट 2, 0. So the corners are, this is the corner and this is the objective. The objective is to maximize 4x plus 3x2. The corner is A, 0, 0. B is 0, 1. C is 1, 2. D is 5/2, 2. Then you have E as 3, 8/5. F as 3, half. G as 2, 0. So we evaluate the objective. For the first corner, the objective is 0. For the next, the objective is 3. For the next, it is 4 plus 6, that is 10. For the next, it is 10 plus 6, that is 16. For the next, it is 4 into 3, 12. 12 plus 24/5. So that gives it 84/5. So this is 84/5. The next, 12 plus 3/2, that is 13.5. The next, you have 8. So the maxima is in fact this 84/5, because this is 16.8. So the point of optima is x1 equals to 3, x2 equals to 8/5, and z equals to 16.8. So this is the optimal solution. So this is the optimal solution of this problem, where we have first calculated the, this is the optimal solution, where first we have calculated the constraints. ये constraint निकाली सबसे पहले, these constraints, and then we got the objective and the optima as x1 as 3, x2 as 8/5, and z is 16.8. There's one more thing, see. This constraint has a -2 on the right hand side. You can also see, if you multiply this by a negative throughout, you can change the sign of the inequality. So this can also be written as, this can also be multiplied throughout by a minus. So this becomes plus, this becomes minus, the sign reverses, this becomes 2. Okay, the region is still towards the origin. 0 minus 0 is less than equal to 2, so that is satisfied. Okay, so these are the constraints in the problem. So these are the constraints of the LPP. Now let us see one more example. Let's say the problem is to minimize W, that is equal to 8x plus 5y. Now the constraints are that x plus y is greater than 20, x is less than equal to 12, x is greater than equal to 5, y is less than equal to 10, y is greater than equal to 6, x is non-negative, and y is also non-negative. Let's say this is the yellow constraint, this is the blue, this is the green, this is the pink constraint, and this is the yellow constraint. So let's plot. So this is the x-axis, this is the y-axis. We have to be in the first quadrant because both the x and the y are non-negative. Next we plot this yellow constraint x plus y is equal to 20. So the line is passing through 0, 20 and 20, 0. And the region is 0 plus 0 does not satisfy. So the region is away. Next we see this constraint. This is a vertical line at x equals to 12. So x equal to 12, you have a vertical line. So this is x equals to 12. And the region is put 0. It is satisfying. So the region is towards. So the region is towards the origin. Next, we see this x greater than equal to 5. So there is again a vertical line at x equals to 5. So let's say this is the line at x equals to 5. If you put 0, 0 is greater than equal to 5, which is obviously false. If it is false, the region is away from the origin. So the region is away from the origin. The next is y less than equal to 10. So the line is this at y equal to 10. If you put 0 is less than 10, so it is satisfying. So the region is towards the origin. So this is the region. Next, you plot this y greater than equal to 6 is again a line at y equal to 6. So y equal to 6 is somewhere there. Y equal to 6 is this line. So this is y equal to 6 line. The region is put 0 greater than equal to 6. So the region is away because it is not satisfying. So this is the region. Now if we see where is the feasible region. Can this be the feasible region? This cannot be the feasible region because it is not satisfying the yellow constraint. Can this be the region? It is not satisfying this blue constraint. This cannot be the region. In fact, this is the triangular region that is the feasible region. Because is area mein every constraint is agreeing. It is to the right of this yellow, left to this blue. It is right of this blue also. It is above this red, below this purple. So this is the region. So the corners are, this is a corner, this is a corner, this is a corner, and the region is, this is the region that is feasible. So I'll just write feasible region. This is the feasible region. This is the feasible region. So the corners are 10, 10. So this is corner A. This is 10, 10. How? Because you see where this line y equals to 10 meets the yellow line. So put y equals to 10. So x is 10. This corner is this line y equal to 10 meeting x equal to 12. So the coordinate is 12 comma 10. This coordinate is where this blue is meeting this yellow. So 12 put कर दो यहाँ पे x की जगह पे, तो y आ जाएगा 8. So the point is, in fact, let's say this is C, let's say this is B. C is 12 comma 8. So the corners are 10 comma 10, 12 comma 10, 12 comma 8. The objective is 8x plus 6y, and we have to choose the minimum. So the answer is 80 plus 60 is 140. 12 into 8 is 96. 96 plus 60 is 156. 12, 8, 96. 96 plus 48. So this is equal to 144. So in fact, the minimum value comes out to be, this is 144. We have to choose the minimum. So the minimum is 140. So this answer comes out to be a 10 comma 10. So the point of optima is x1 equal to 10, or y equal to 10, and z equals to 140. See, the point that I was trying to make with this example was this constraint. See this constraint. First see this constraint, and then you see this constraint also. Let's say this constraint was not there. So ये वाली constraint अगर problem में नहीं भी होती, had this not been there, this is again the feasible region remains the same. So this constraint, this red constraint, is a redundant constraint in your problem. Because its removal does not alter the feasible region. Similarly, see this constraint, this blue constraint. If you delete this constraint, the triangular region remains the same with those three vertices only. So this blue constraint is also, this blue constraint is x equals to 5. So this constraint is also a redundant constraint. So this and this. So these two constraints are redundant. If you remove this from your problem, the feasible region of your problem does not change. That means there was no need for these two constraints. And these types of constraints in your problem give rise to what is called as, they give rise to degeneracy in the system, which is a concept we'll see later in the simplex algorithm. This gives rise to degeneracy. And these cases, these types of constraints should be avoided. Okay, तो वो जो सीधी एक constraint थी x equals to 5 वाली, ये वाली, but क्योंकि question में है तो बनानी तो पड़ेगी, but these types of constraints should be avoided. Okay.